Hi everybody, this is Mr. Grash. Welcome to a quick little lesson on C7. So just wanted to mention quickly, this really plays into what you should already know about ions, so forming cations and anions. These two guys right here. And then it mentions you always have a cation, which is typically a metal, and then an anion, which is typically a non-metallic atom, such as like oxygen or something like that. There's another note here in the notes. It just mentions ones that share electrons are molecular compounds. So if you've been following along, this is actually a part of C6. Okay, so binary ion compounds consist of just a single metal and non-metal. Okay, naming them actually is relatively easy. So the first element, which is typically the cation, you just literally write the name. So for this first example down here, we have NaCl. Na, if you look in the periodic table, is sodium. So we just simply write sodium. Okay, I tend to write in all caps, but typically when you write names for compounds, you want to keep it in all lowercase. Okay, the anion, we just changed the ending of the name to IDE. So down here we actually have chlorine, but we're going to change the chlorine to chloride. Okay, so it has that IDE ending. Okay, so something I didn't mention up until now is unlike moleculars, we do not use prefixes when naming ionic compounds. Okay, with ionic compounds, we just write them as is. Sodium chloride, there's no mono, di, tri, nothing like that. That is only for molecular compounds. This is something that's very common in Science 10. A lot of students seem to think that prefixes are needed, or they mix up whether they're naming a molecular or ionic compound. So that's something to watch out for. The second one here, we have Ca and S. Again, if we take a look at the periodic table, Ca is calcium, S is sulfur. So we'd write the name of the cation first. Calcium, and then S is sulfur. Again, if you take a look at the periodic table we provided you on D12, it'll actually show you the actual name when it forms an ion, what the name should change to. Okay, for most of the cations, the name is unchanged, but anions, it will usually end in the IDE. Okay, so in this case, we change it to sulfide. Okay, so sulfur becomes sulfide. Okay, next one, LiBr, lithium, bromine, so it becomes lithium bromide. Okay, so pretty straightforward. MgF2, so even though it says a 2 on it, again, we don't put prefixes. So Mg is magnesium. And fluorine becomes fluoride. Okay, they all have this IDE ending. Okay, so now we're going to move on and talk about how to take the name, if we're given a name, and write the formula. Okay, so we're going to move backwards. There's some steps here. Okay, so it tells us, writing the formulas for ionic compounds, we first want to determine if the compound is molecular or ionic. So that's a good step, identifying if it's molecular, meaning it'll need prefixes, or ionic. Okay, if it is ionic, we want to figure out the charge of each ion. And we can do that either through what we've learned about valence electrons, or we can use the periodic table and just take a look at them. From there, we need to balance the charges. This is one of the most important steps, and we'll show you how to do that with our first example. Okay, so that's where the subscripts come in. Those are different than the prefixes. Be very careful with that. And then if needed, this is a necessary step, is reducing to the lowest whole number ratio. So if that comes up, we will talk about it. Okay, so the first example we have here is aluminum chloride. And it tells us it's ionic, but we can also look. It has that IDE ending, and we have a metal, aluminum, which is a cation, and then chloride, which is an anion. So we have a cation, a positive, and an anion, which is a negative. So we do have an ionic compound. Okay, so let's start by writing out the charge. Aluminum, if we take a look, is Al, and it is 3 positive. Okay, and then chloride is Cl minus. It's 1 negative. Okay, so then we think to ourselves, 3 positive. What that means is when it forms an ion, it has 3 more protons than it does electrons, which means it has given up 3 electrons. Okay, so it wants to give away 3 electrons. Chlorine is Cl minus, so it wants to gain just a single electron. Okay, so if we have 3 positives and 1 negative, what we need to do is we actually need more chlorine. We need to have the same number of negatives and positives so the exchange can be complete. Okay, so we actually need 3 chlorines here. So I'm just going to draw little arrows for the donation of electrons. Aluminum is going to give 1 to that chlorine, 1 to this one here, and a third one to that chlorine. So it's able to give up 3 electrons, and then our anions are able to gain those 3 electrons. Okay, so what that looks like as a chemical formula is AlCl3, because we have 3 chlorines. It goes on to say, do you need to write the 1 subscript? No. If there isn't a subscript, we assume that there is 1. In this situation, we don't need to reduce. So our final formula, again, is just AlCl3. Okay, let's continue and try a few more examples. Okay, so let's take a look at these ones. We got barium fluoride, lithium oxide, and aluminum sulfide. Okay, so all 3 of these are ionic compounds. Barium, lithium, and aluminum are all metals. Fluorine, oxygen, and sulfur are all nonmetals. Okay, so again, we want to start by writing out the charges. Okay, so something like barium, Ba, 2 positive, fluorine is an F, and 1 minus. Okay, so barium wants to give up 2 electrons, it's going to give 1 there, and we need another fluorine to accept the other electron. Okay, so we get BaF2 because we have 2 fluorines in total. Lithium oxide, lithium, if we take a look at the table, is Li+. Oxygen in this case is O2-. Okay, so this lithium wants to give up 1 electron. It's happy. Oxygen wants to gain 2, so it's actually unhappy. So in this case, we actually need 2 cations, so we need to add another lithium to donate that electron. Okay, so now we have 2 positives, 2 electrons being given up, and 2 negative, 2 being gained. So our formula looks like this. Li, we have 2 of them, and then 1 oxygen. Okay, aluminum sulfide. Aluminum is 3 positive. Sulfur, just like oxygen, is 2 negative. Okay, so this one's a little bit more tricky. I'm just going to take a quick step, do a little math lesson. Obviously, 3 and 2 aren't going to work out too well, so if you really quickly think, what is their lowest common multiple? Count by 3s, you get to 6. Count by 2s, 2, 4, 6. So we know we're probably going to want to have 6 positives and 6 negatives at the end of this. Okay, so we're going to give 2 electrons up here. This aluminum is going to give 1 there. So we'll need another. And we'll need another. Oops. And what? Sorry. And then we'll need another aluminum. It's going to donate 1 electron to the sulfur in the middle, and then 2 to the sulfur at the bottom here. Okay, so again, those arrows are just showing you where the electrons are going. Our formula, we have two aluminums, so Al2, and we have three sulfurs, so S3. Okay, one common error is a lot of students think that the subscript actually represents the charge of the ion, which is incorrect and will get you a lot of wrong answers. So make sure when you first practice these, I really advise drawing out the charges and how many of each ion you need, and think to yourself, where are these electrons going? It might take you a little bit longer, but practicing it this way will make sure that you understand what is happening with the electrons and will, in the long run, help you with naming both ionic and molecular compounds down the road.